Good morning to everyone. My name is K. Madhavi, Assistant Professor in the Department of Mathematics. So, Annamacharya Institute of Technology and Science, Tirupati. Today, yesterday class, today I will discuss about the Model 2. Okay. So, yesterday I will explain the what is the introduction of the queuing theory and what is the definition of the queuing theory and examples. What is the depends upon the various types of queuing system. So, and model 1. Model 1 explain the previous class. Today, today I will discuss about the model 2. So, model 2 is indicates, model 2 is indicates the single channel unrestricted queue with finite population, with finite population. So that is finite population means you have to indicate capital N. Okay. So this is the second model, assuming the this one. What is the next assumptions in the second model? What is the assumptions? Assumptions of this model. This is the same first problem assumptions. Only one thing. That is one thing will be changed. The arrivals are from finite population. So we have to denote it capital N. Same remaining assumptions are same. So first, in the first method, this is the infinite population. This method, this is the finite population. So the remaining characters are same. So first, what are the formulas included in this model? So this is the symbolically notation for MM1, MM1. This is N of Fs, Fc, Fs. Okay. The Kendall notations symbolically second model is denoted. N is the finite number of things. FCFS is the first come first service. So MM1. MM1 means we have to indicate the first method. That is the finite population. Okay. So what is the formulas included in the second model? That is first the relationship of these models. First you have to observe that let their M is the units in the source population. Here, M is the source population. And 1 by lambda is the average interval or average time between the service arrivals. Okay, here we have to average time is indication by 1 by lambda and the mu is the service rate. Okay, so here we have to discuss about the probability of the system shall be ideal. Probability of the system will be ideal. Which formula we can use? So that is ideal means this is the P naught is equal to summation of I is equal to 0 to m factorial by m minus I factorial into lambda by mu whole power I, that is the whole inverse minus 1. So what is the next thing? That is the probability of n customers. The second formula is probability of n customer. This is two cases arises. The probability of n customer is, that is 0 less than n less than or equal to m. That if Pn is defined as like this, and the n customers is greater than m means we have to simply written 0. Okay. So here M is the source population and lambda is the 1 by lambda is the arrival time and the mu is the service rate. Okay. So here what is the next? Next formula is expected length of the queue. Expected length of the queue means that is symbolically represented as LQ is equal to, that is M minus lambda plus mu by lambda 1 minus P naught. Here M is the source parameter, LQ is the length of the queue and lambda is the arrival time and mu is the service rate. Okay, so what is the next formula? The next formula is you have to calculate the waiting time in queue. We have to calculate waiting time in queue. So what is the formula involved? That is, so is indication for WQ. The formula is 1 by mu m by 1 minus P naught minus lambda plus mu by lambda. Here in the queue, waiting time. Here in the system, the waiting time is, that is expected waiting time is indication for symbolically WS is equal to 1 by mu into m by 1 minus P naught minus lambda plus mu by lambda plus 1. Here we have to use this one or WQ plus 1 by mu simply. Okay. Here the expected time in the queue and expected time in the system. Those are the formulas included in the second method. In second method is also the formula basic problem. Here, what is the M? The denotions are what is the M and what is the lambda and what is the mu. Here, M is the source parameter and 1 by lambda. Here, 1 by lambda is average interior. That is the time between the successive arrival time between successive arrivals, and the mu is the service rate. Here you have both formulas which can be added. Depends upon the problem. First we have to select one problem. The problem is in a factory. In a factory having 5 machines. Breakdown occurs randomly and average time between the breakdowns is 2 days. Average between the breakdowns is 2 days. Assuming that the repairing capacity of the workman is 1 mission a day. 1 mission a day. Okay. So 1 mission a day. Or simply you have to some textbook 1.5 mission per day. And the repairing is distributed exponentially determine which values you have to determine. First one, the probability of the service capacity, that is service facility, will be ideal. That is, we have to find out the P naught. And the probability, what is the second question? The probability of various numbers of missions to be and being repaired. Okay. So next, what we have to calculate the next value is, that is, next we have to calculate the expected length of the queue. Expected length of the queue. Next, expected number of missions waiting to be being repaired, and expected time in the machines shall wait in the queue. Okay, shall wait in the queue. Next, expected time, a machine shall be ideal for reason waiting to be repaired. So you say 6 questions will be asked. So which already the above method you have to explain the all formulas will be explained before. So first you have to calculate the probability of various number of missions to be being repaired. So the given data has written like this, that is the single server model, unrestricted and finite population. And finite population. Here we have to use the finite population. The factory has 5 missions. The before problem and model 1 and model 2. What is the difference between these both models means we have to specify the mission numbers, and those only 5 missions may break down at the utmost. So this the calling population. Okay, so this the m is equal to that is m is the defined for here 5 missions service rate, that is m is equal to 5, and lambda is equal to here 2 missions per day. Already we know that here in second method we have to use lambda is equal to lambda is that is m is the source rate and 1 by lambda is arrival time and mu is the service rate. Here m is the use for source parameter. Here 5 missions have the m is indication for 5 missions, that is source, and lambda is equal to, so per day 2 means each day, that is 1 by 2 missions, and mu is a, so 1 mission, that is mu is equal to 1. Here we have to calculate rho, that is rho is, what is the formula is rho? The formula is rho is lambda by mu. Here substitute the lambda and mu values, they will get 0.5. And so after calculating rho value, they will calculate the probability that service facility will be ideal. The probability of service facility will be ideal. So ideal means what we have to use the formula is P naught is equal to here. So P naught is equal to this formula we have to use, that is P naught is equal to summation I is equal to 0 to m, that is m into m naught m factorial by m minus I factorial into lambda by mu power I whole power minus 1. So this formula you have to use. Here m is the service rate and lambda is the, and lambda and mu is indicates the arrival time and service time. So here you have to substitute the formula, calculate. 5 is the, m is the source parameter. You have to substitute I is equal to up to 0 to 5. And here m is equal to, that is 5 factorial by m minus I is 0, and lambda by mu whole power I is 0, lambda by mu is 1. So they will get the, this factor is calculated, this is P naught whole value, that is indication is summation of this m factorial by m minus I factorial into lambda by mu whole power I whole power minus 1. Calculate this value, they will get the 1. So substitute here I is 1 and calculate the m factorial by m minus I factorial, and lambda by mu is whole power I is 5, that is 0.5. So calculate the which includes the formula is, so substitute the above formula, they will get 2.50. So up to 5 you have to same formula we have to use and calculate the, so the service facility will be ideal. The total value is 27.25. Okay, so here what is the next value calculated between the probability of various numbers of missions to be repaired. Okay, so various numbers of missions to be repaired means which formula will be will be written. So that is Pn is equal to, we have to go to the formulas. So Pn is equal to, so here the probability that there are n customers in the system. So the value is the lines between the 0 less than n less than or equal to m. We have to use the formula, that is P naught into lambda by mu whole power n into m factorial by m minus n factorial. Here we have to use the formula like this. So here n is indication for m is 5 and 0 less than n. N here use 0 and here 1 is lies or is greater than or equal to m. The condition will be satisfied. So that's, we have to use this formula. Okay, so we have to calculate the P naught. P naught, that is, so P naught means 0.03670. So substitute, already we have to calculate these values, that is P naught, what's the value here? Here, so the value P naught substitute this the equation, they will get the answer is 0.03670. What is the next thing? Substitute n is equal to 1. So n is equal to 1 means they will get this solution. So P naught is 0.03667 and this is 0.5 and this one we have to calculate. The total value is like this. So same, in the same manner up to 5 P2. P2 is equal to, substitute in this equation, n is equal to 2. So they will get some resultant. In the same manner we have to calculate up to P5. Okay, so this is the P2, P3, P5. So these values are, that is the various number of missions can be repaired. For example, P1 first mission, P2 second mission, third mission, like this. Okay, so what is the next question will be asked? So that is, we have to calculate the expected length of queue. Expected length of queue means, so the formula is m minus lambda plus mu by lambda 1 minus P naught. So here m is the service rate. This is lambda and mu. M values will be substituted. the above formula, they will get 2.11 mission. Okay, so next will be asked the expected number of missions waiting and being repaired in the system. So in the system means, so we have to use the formula in the system means we have to use the formula L of S is equal to M minus mu by lambda 1 minus P naught. So they will get the 3.07 missions. Okay, this is the expected number of mission waiting to and being repaired in the system. So this is expected time mission will be wait in queue being repaired. That is the mission shall wait in queue. So wait in queue means we have to use the formula 1 by mu into m minus p naught lambda plus mu by lambda. So both values will be calculated and substitute the values. They will get the resultant 2.19 days. So next we have to ask the expected time a mission will be in system. Expected time, that is expected time, you go to the formulas. Expected time is, so this is the expected time in the system. Sixth formula, we have to use the WQ plus 1 plus 1 by mu. So this is how to use this the formula. So they will get 3.1 days. So the model 2 is various formulas will be included. So here n is the finite number. So in second problem, you have to see the second problem. The same first problem information you have to take. What is that? For the data given in first problem, using the following information, obtain the expected cost per breakdown. So we have to calculate the expected cost. The mission will be ideal time is 160 per mission per day. The operator cost is 40 and worksman charges is 70. Okay, so given data is this one. You have to calculate the total cost. Total cost means we have to use the formula the mission ideal time plus lost productivity of operator plus cost of repair. These three values will be calculated. Finally, we have to add the three values. They will get the total cost. First, we have to calculate the mission ideal time cost. Okay. So, mission ideal time cost. So, the mission ideal cost is, the formula is ideal time and ideal time of cost. So ideal time and ideal time of cost. Ideal time means that is WS, and ideal, that is the ideal time for cost is 160. So they will get the value after simplification like this. So what is the second thing? Lost productivity of operator. Lost productivity of operator. The formula is the ideal time of a mission into operator or operator cost by number of missions. So these the formulas. Substitute the values, that is ideal time of a mission and operator cost by number of mission. Here 5 missions, operator cost is 40 and ideal time of a mission is WS. So our values, both values are substituted, they will get the required solution. And what is the third thing? What is the third thing? Cost of repair. The cost of repair means, so the repair time and the repair rate. Both multiple the repair time and repair rate, they will the cost of repair. Okay. So the values, repair time is, and the repair time, we have to calculate the repair time means, so in the system, WS minus WQ. Okay. So into repair rate is given 70. So after calculating this value, they will get 70. So three values will be calculated, then the total cost will be given. So that is, what is the first thing? The mission ideal time cost and the lost productivity of operator and the cost of repair. So after adding the both values, they will get the required solution. So next problem, we have to see the next problem. So what's the in the same previous first type problem, that is the a laundry has 6 washing machines, is given a finite value 6 washing machines. Break down the randomly and the average time interval between the successive breakdown is 4 hours. The machines breakdown required on an average 45 minutes. 45 minutes to repair. The service time being exponentially distribution. Using this information, you have to require to determine. So the values will be given. First, we have to find out the probabilities. 0, 1, 2, that is the ideal of 0, 1, 2, 3 missions in the system. Next, the waiting time of a mission in queue. Next, expected number of missions in the system and the expected number of missions in the queue. Okay. So here M is 6 washing machines and the lambda is here indication of 1 by hours, that is 1 by 4, and mu is 45. Here we have to see 45. Here 45 minutes. 45 minutes can be converted into the hours means 60 by 45, that is 1 by 1.33, and that is rho is equal to, what is the formula? Lambda by mu. So calculated the rho value and mu, lambda and m. So first we have to go to the A. A. First, what is the A? Will be asked the AB. So that is probability of n missions in the system. What is the A? The probability of n missions in the system. Here we indication of 0 means, that is we have to use the ideal. So what is the P naught formula? P naught formula we have to use, that is summation of I is equal to 0 to m factorial by m minus I in factorial, lambda by mu whole power I, that is whole inverse. Here 6 system means you have to calculate the 6 systems, that is I is equal to 0 to 6. So m is 6 and I is 0. Lambda by mu is calculated. The whole value, this is a multiple of these two values. They will get this one. So multiple of these two values, they will get this one. The total is this. So we have to calculate, this is 4.58 whole inverse. They will get the P naught value. And Pn. What is the Pn formula? P naught into lambda by mu whole power n, m factorial by m minus n factorial. Okay, so this is the formula. Substitute n is equal to 0, 1, 2 like this. They will get the required solutions up to how much value? Up to 6. Okay, so next, what is the expected waiting time in the mission? Expected waiting time in the mission means we go to the formulas. We go to the formulas. What we have to do is WQ. WQ, expected waiting time. Expected waiting time is indication for WQ. That is 1 by mu m into m by 1 minus p naught minus lambda plus mu by lambda. In the same formula, we have to use, that is we have to use this one. So after substituting the values, they will get the WQ. So next, expected number of missions in the system. Expected number of missions in the system means what is the formula? Is L of S. L of S is equal to m minus mu by lambda 1 minus p naught. Substitute the m, mu and lambda values. They will get the waiting missions value will be required. And what is the D? Expected number of missions in the queue. Expected number of missions in the queue means the formula is LQ. LQ formula is, what is that LQ formula? M minus lambda plus mu by lambda 1 minus P naught. Okay, so that is the, in this model we have to calculate the expected number of missions in the queue, number of missions in the system, and expected time in the mission in queue, and we have to calculate the probability of n missions in the system. So both three problems will be calculated in method 2. Okay, so this is method 2. We have to explain three, we have to explain the, in second method explain the three problems. Okay, thank you.